Our goal is determining key features of a quadratic without the use of technology. So if you watch the previous video, we're going to again talk about these things: zeros or X-intercepts, solutions, roots, whatever you want to call them, but they're all the same thing. Turning point or points, it's going to be singular, not really needing to put plural there. Turning point, the Y-intercept, which is definitely singular, and axis of symmetry. So without using technology, so far you may have seen quadratic functions or parabolas written with these sorts of equations here. So you've got y equals x squared, we've got y equals ax squared plus bx plus c, we got y equals a outside of x minus h all squared plus k. And yeah, these are all types of representations for quadratic functions. So essentially we're going to basically find those or determine those key features, and we're going to use three examples that I've just added to the screen. The first one doesn't have any variation, basically y equals x squared. So if we're looking at zeros, and look, by the way, we're doing this without sketching and without technology. So without sketching is what we're doing, and of course no technology, because that's the title of the video, it's what it's all about. So without cheating, not that it really is cheating, but without cheating and drawing a graph, how do we know what the zeros are? Well, we're talking about the x-intercepts, aren't we? So how many times does it cut the x-axis, if indeed it cuts it at all? Well, the x-intercept or zeros, x-intercepts happen when y equals 0. You should know that from your previous work. So we set y equal to 0 here and solve it, and the only solution is x. 0 squared is 0. So it has one x-intercept and it's at x equals 0. And in fact, when y equals 0, x equals 0, it'll be actually touching, if you draw a parabola, it would actually be touching the origin, which is 0, 0, and it only cuts through one point. So that's also the turning point. So when we look at whether it's going to be a max or a min turning point, we look at the coefficient of a on the front, that number there, if it exists. Well, it does exist. The coefficient there is 1. It always has a coefficient, and there. So if it's positive, alright, we have a minimum turning point parabola, and we have a maximum turning point if the a value is negative. So if a value is negative and if the a value is positive. Okay, some people think positive, smiley face. Okay, negative, frowny face. Okay, so what else do we have to find? Well, that is the turning point too. It is the lowest point on the graph. We need something more rigorous to show that, but I'd like to draw your attention before we continue on over here. I want us to look over here. What we have is the parabola in what's called turning point form, and that's important. Turning point form of the quadratic. So very important. Turning point form is this one over here. Y equals a outside of x minus h plus k. And from a previous video you have seen this, that the turning point is, now that needs to be a minus for this to come straight out, h comma k. So the turning point here would be from looking at these. So the hk here, well, the k is actually quite easy to determine. So the hk would be, k is 4. This, as I said, needs to be in subtraction form, so you have to minus a negative So it's negative 1, 4. Now we've seen that in a previous video. If this one was in turning point form, we would have to figure out what A, H and K are. So A equals 1, we have H equals 0 and K equals 0, because to get it into the turning point form, we've got x squared over here on the left, but we've got minus 0 there, because x minus 0 all squared is x squared, and we've got plus 0 on the end. There's nothing there, so it's plus 0. So we've got the turning point, and it's 0, 0, which lines up with what we said. Okay, so we'll put that in. It's good to label their work. So turning point would be 0, 0. The turning point is the same as the x-intercept, or the 0. So moving on now, the y-intercept. Y-intercept is when x equals 0. So we've got y equals sub it in 0. So 0 squared is 0. So basically it cuts through when x equals 0, y equals 0, so the y-intercept is also 0, 0. So that's interesting, isn't it? We call that the standard parabola y equals x squared. Its turning point, x-intercept and y-intercept are all at the origin 0, 0. The axis of symmetry is going to be in line with the turning point, the x value of the turning point. So it'll be x equals 0. In other words, that's the y-axis, isn't it? So that's our standard parabola. Moving on to the center one, I'm going to leave that to last, okay, just to be enigmatic and arouse some curiosity. Okay, so I'm going to leave that one till last. We're going to do this other one here. It's given in the turning point form. It's a quadratic, and what we need to do is find those things, the zeros first. Okay, so it's the same situation. The x-intercept, or the 0, is when y equals 0. So x-intercept is when y equals 0, or it might be intersects. So we set it equal to 0. So that equals 0. Notice how the negative sign is on the outside. We've got, then we subtract 4 off both sides. We times both sides by -1. Take the square root of both sides, so that would just leave x plus 1 here. So it's plus or minus 2, because the square root of 4 is plus or minus 2. So we have x. Let's look at the positive. So if something plus 1 is 2, x equals 1, or the negative. So what plus 1 is -2, -3 plus 1 is -2. So the zeros are given there. To be proper, write them as a full point with ordered pairs, 1, 0 and -3, 0. So next we had to find the turning points. Now we've already done that earlier in the video, so I'm just going to remind you that we did that just before. The y-intercept is when x equals 0, so let's do that one. So 0 equals sub in 0 now. Sorry, y equals. There we go. So y equals negative, so sub in 0, 0 plus 1 squared plus 4. So we've got negative of, what's 1 squared is 1, so it's -1 plus 4 is 3. So the y-intercept is the point 0, 3. Then we've got the axis of symmetry. The axis of symmetry is an x equals line, vertical line. It's not a function, therefore, is it, if it's a vertical line? So it's x equals line that's in line with the turning point's x value. So that turning point, because it's symmetrical, so the turning point is at x equals -1. So that'll be also the equation for the axis of symmetry. Okay, so we've got that done now. If you did end up taking a quiz on graphing software, you'd see that those are correct, those points there. So that's good to know. And by the way, there is a second way of considering the axis of symmetry too, where it lies. If we look at the zeros for parabolas that have two zeros, you might remember it was cutting the x-axis at those 2 points. If you find the median or the middle point in terms of the x-coordinates, the middle position, it's halfway between -3 and +1. That's a gap of 4, so if you go 2 either side, you'll get to x equals -1. So that's a second way. So you just find that 1 plus -3 over 2 would be the calculation you'd show. So that's a second way of doing that if you prefer. So 1 plus -3 over 2, you'd write that there. Okay, and that'd be -2 over 2, which is -1 as we got. So that's a second method of getting the x equals -1 axis of symmetry. Now back to this elusive last one in the ax squared plus bx plus c form, and you know, the reason why it's good to be able to complete the square is that it allows us to convert that form, that expanded form, into the turning point form, which is quite handy in some situations. So just to save a bit of time in the video, I've pre-printed the solution in front of you there, so you will need to pause the video at times here. But when we've got the given quadratic, we are able to take out a factor out the front. It might make the completing the square part easier with the smaller numbers. It doesn't go away, it's still there, but it just sits out the front. Okay, so it's factorizing to make life a bit easier. So we've got really the inside the brackets is what we're going to complete the square on. Okay, so starting the completing the square, remember from the previous video, that's the form. A is obviously x, 2ab would be positive 3x, or negative 2ab would be negative 3x, but basically we can lose the negative off both sides there, which I've done, and we can already use the known fact that a and x are accounted for, so 2b equals 3, so b is 3 on 2, okay, 1.5 if you prefer. So that's how we have to complete the square, and you can see what they've done there. They've got added a b squared term on there. Of course, outside of that completed square, we have to also subtract what we've added on, okay, and reconcile that with the given 4. And we've done this before in class, basically. So it'll be basically 9 on 4 take 16 on 4. Sorry, it'll be the other way around. It'll be minus 9 on 4 plus 16 on 4. And that will leave that 7 on 4 you can see on the outside. But the rest of it we use completing the square on, which we've seen in the past videos. So that bit there is a perfect square leading to that. And so now we're in turning point form. So I've done the hard yards first on this, because that was one of the main things I wanted to show you. So we've got h and k, we've got h is 3 on 2, k is negative 7 on 2. And you can see that written there. The axis of symmetry will line up with the turning point's x value, so you see that there. The y-intercept is when x equals 0, so you can imagine subbing in 0 there, subbing in 0 there. Those two terms are essentially 0, and you've just left with y-intercept equals -8. So it cuts through at 0, -8. So not much left to do now, almost done. Now this is where experience counts. To find the zeros, if you tried to factorize that, you're going to have a pretty tough time. And when you've got that sort of thing, you know, just to be sure, turn to the discriminant, which we've talked about previously, and if the discriminant is less than 0, there will be no roots, no x-intercepts. And it is, because if you sub that in, we end up with 36 minus 4 times -2 times -8, and that will come out as a negative, because that's 36 takes 64, it's 0. So there are going to be no real solutions. Okay, so there are no solutions in the elements of the real number set. So in math methods, specialist maths is different, but in math methods that's it. There's no solutions, so no x-intercepts.